I'm going to have a look at question 6. Some of you I already know are past this. If that's the case, I want you to have a look at the way I've set this out so that you can make sure you do it in a similar way. Some of you are not. Some of you are thinking, and you're a little confused by it, so let me try and walk you through it. Now, I keep on calling you back to when did we first meet the idea of these inverse trig functions? And the answer was triangles, right angle triangles specifically, and you could find, using these guys, you could find angles, right? And I kept on going into that sine inverse of 3/5 example, which is 37 degrees. And when you have a look at this, therefore, you can apply very similar logic, but I'll just give it to you with a caution, which is to remind you that cos inverse, sine inverse, tan inverse, okay? You can think of them as angles in triangles. You can think of them as angles in triangles, but they are not only angles in triangles, okay? They have much broader applications than that, and you've already seen some of them, okay? But it is a very helpful way when you think about this. So have a look at this. One piece at a time. Let's look at this inside bit and see if we can understand it. Cos inverse of 3/5. If we think of it as an angle in a triangle, what kind of triangle would it be? Now, because we're just thinking about a ratio, it must be a right angle triangle, right? So, over here, I will draw a right angle triangle. Wow, that's a terrible right angle. Sorry. You get the idea. Now, cos inverse of 3/5. That tells you that there's a ratio of two sides here, 3 and 5, right? That's the ratio. It could be, 6 and 10, or I could multiply by any factor and I would still have the same kind of triangle. The ratios would be the same, right? So to me, it looks like this would be the 3 and this would be the 5, right? Where is this angle? If I call this angle theta, where is theta? Cos inverse of 3/5. Cos is adjacent or hypotenuse, isn't it? Right? So that's always the hypotenuse. But the angle for which this is the adjacent side, that's a terrible sentence. The angle for which this is the adjacent side is this one, right? That's adjacent to the 3, not this one down here. Okay? So therefore this angle, really, this is cos inverse of 3/5. Or it's equal to that anyway. Okay? So now if I want to work out what sine of that angle is, sine of theta, okay, all I need is the opposite side, and then it's just opposite on hypotenuse, right? Well, it's right angled, so the other side, of course, is 4. So it's opposite on hypotenuse, 4/5, okay? No problems. I think you'll quite master that. In fact, eventually you'll stop drawing triangles, and you'll think, that's a Pythagorean triad in there, right? And you'll start to work it out. It's not that hard. But they throw a spanner in the works by chucking negatives in. Have a look at question part 5. This is part 1. Now I know you can't see the screen, so I'll just write it out for you. Now have a look at this with me. What does this add to things? Okay, this negative, right? It does make things more complicated. It breaks down this. Okay, I can't use this diagram any longer. Can anyone tell me why? It doesn't account for the fact that something's going to be negative because everything here is positive. Okay, so therefore what I'm going to do is I'm going to draw myself a quadrants diagram. I'm not a huge fan of quadrants diagrams, but they can be a helpful tool. So you have a look at this. Okay, by the way, all stations to central, as you will see shortly, we will never have to worry about this guy. I wonder if you can tell me in 5 minutes why. Okay. Now, you start again from the inside. You go from inside out. You start from the simplest thing, and then you add more stuff to it. Okay. Now it's a tan inverse ratio, right? And it's negative. So out of these 3 quadrants, right? Which quadrants are my options? Well, tan inverse. What is the range of tan inverse? What's the range of tan inverse? We looked at this. We graphed it before. It's from negative pi on 2, call it theta, to pi on 2, right? That's where it's locked in. Which quadrants are those? Which quadrants does this range represent? Answer, it represents these 2, 1 and 4, right? Because this second quadrant, these are obtuse angles. There are no obtuse angles in this range, right? So these are my options. Then I say, okay, it's negative. That restricts my options further. Where is tan inverse going to be negative? Is it this quadrant or this one? And the answer is it must be this one because they're all positive up here, right? So I ditch this guy, okay? I'm going to form a triangle down here, and its ratio is going to be, for tan inverse, that's opposite on adjacent, right? Opposite on adjacent. Opposite is going to be length 1, and adjacent is going to be length 3. Okay. Now this will take some practice. Okay. I've done this millions of times. That's why I know where to draw it straight away. That means my angle is going to look like, my triangle is going to look like that. Can you see why? If I have my angle in here, theta, okay, the opposite side is the -1, okay, and the adjacent side is the +3, okay. Can you see that? Can you see what's going on? Now obviously, if I went over here, tan would still be negative, but it wouldn't be -1/3. What would it be? It'd be 1/-3 because I'm in a different quadrant. These are x's and y's, right? But I already know I'm in this quadrant, okay? Because of the domain, the range of tan inverse. Okay. So now I've got my theta. Now I can see where theta is, so I can work out what cos theta is. I need adjacent and hypotenuse, right? I've got the adjacent. What is the hypotenuse in this case? Square root of 10, isn't it? Yeah. Okay. So therefore, this is adjacent on hypotenuse. That's 3 on root 10, and the textbook answers very awkwardly rationalize it. They give you that, but 3 on root 10 is fine. Okay. So do you see what I did there? There's quite a few steps to this. Let me walk through them again. First, you start off with the question. And you want to say, well, look, inside here there's a tan inverse. So that locks in this range. That tells you what the possible quadrants are. Okay? Then you look at what the actual value in there is, and that tells you which of the two quadrants you actually are after. Once you've got one, you use these two to draw in your actual triangle. Okay? And be careful which side is which. You have to think about, oh, it's opposite and adjacent. That's why my -1 and my 3 are exactly where they are. And then you think, finally, I need to take cos. That's the easy part, isn't it? Okay. The hard part is in the construction of this and making it accurate. Having the 1 and 3 in the right spots and making sure it's, well, cos is positive. That's why, yeah. Okay. In fact, cos has to be positive because A, C doesn't actually matter. Okay.